Let's look at number 10 on the quiz, because a lot of people got it right without doing it right. Right answer, wrong way. And I didn't. By the time I realized it, I had already graded more than half of them, and I didn't want to go back, so I just gave you credit and then made a mental note that we would look at it today. So there's number 10. Some of you split that up using illegal algebra. Throw you in algebra jail for what some of you did. Both of these have a sign on them, both of these terms. So that means I can factor out that sign. And that would leave 1 minus cosine x over x squared. And then if you make it that far, you're like, oh, I can put one of these x's under the sign.
And one of the x's under...
And one of the x's under 1 minus cosine.
1 times 0 is 0.
Because those are exactly the two things that we're supposed to know. That one's equal to 1. That one's equal to 0. And 1 times 0 is 0.
So that's legal.
All of that was legal. What some of you guys did was illegal.
I'm sorry, I committed crimes.
You committed crimes against algebra. For that you will be punished severely. Anything else from the quiz that maybe you got the right answer, but you still weren't sure exactly what happened?
2e.
2e. Let's look at the picture here. So that one's sort of a substitution one. So you plug in 2 for x. 2 squared is 4. And then f of 2. Although I don't really want f of 2. I don't want f of 2 because that would be 1. I want the limit as x approaches 2. So this part was just substitution, but the second part we had to make sure you use the limit, not the function value. And then 4 times 2 is 8. So that one was a little bit tricky because part of it was direct substitution, but part of it was looking at the graph and using the limit where the hole is, not necessarily where the dot is. Good questions. All right, how about questions from page 79? Kate? 33. Piecewise functions. So the question for 33 says, discuss the continuity of the function on the closed interval. So again with the discuss. 3 minus x, that's a polynomial. 3 plus half an x, that's a polynomial. So both of those, like taken on their own, are continuous. So I'm not worried about them. What x value am I worried about? 0. Because there might be a jump when it goes from sort of branch A to branch B. So I really want to know what's going on at x equals 0. And even though you didn't have to do the formal limit or the formal continuity definition for this problem, just for practice, I'm going to use that definition to kind of guide my thoughts here. So the 3-step proof: function exists, limit exists, they equal each other. Got to know that. Continuity. Function exists, limit exists, they equal each other. So f of 0, well, I would be plugging into option A there. So the function exists. 2, the limit exist? Question mark. I'm not sure yet. That's what we're looking for. So how do I check to see if that limit exists?
You look at the stuff next to it.
Okay. So I need to look at the stuff to the left of it and the stuff to the right of it. So I need to see what's going on just left and just right. So if I'm just left of 0, that would put me on branch A. 3 minus 0 is 3. If I'm just right of it, that would put me on branch B. 3 plus half of 0 is 3. But since they're both equal to 3, thank you, that means the limit's equal to 3. So they do come together and hit at the same spot, at 0, 3. And then lastly, I'm just looking to see if the function equals the limit, and it does. So check, check, check. So this is continuous at 0. Although let's back up. It wanted me to discuss the continuity of the function on the closed interval. So 0 is my only concern. So it's continuous at x equals 3, which for this particular problem means it's continuous on that whole interval. If I graphed it, let's see if I can graph this quickly here. 3 minus x, when x is less than 0, would be like that. 3 plus half x, when x is greater than 0, would look like that. And so yes, it is continuous. They meet up at 0. But the heart of that problem was this left and right business. You've got to check the left and the right and see if they are equal. What else from 79? All right, so that was a piecewise function where everything worked. I want to do number, let's see, I want to do number 40, no, I want to do 61. And 49. We'll do 61 first. Both of these are inspirations for test problems. So 61, the directions say find A to make it continuous. So what value of x am I really concerned with for this one? 1. So I need to make sure. I did the formal thing last time. This time I'm going to do an informal thing. I mean, it's the same thing, but one's formal and one's significantly less formal. I just want to know if coming from the left, if that equals coming from the right at x equals 1. So officially, formally, I'm checking the limit at 1. Unofficially, I just got to plug into, let's see, from the left, that would be branch A. So that would be 3 times 1 squared. And I want to know if that's equal to, from the right, that would be, oh, I got these backwards, didn't I? Because they wrote them backwards. From the right should be branch A. Start over. From the left, branch B. A times 1 minus 4. From the right, let's slow down here, where x is bigger than 1, that would be branch A. 3 times 1 squared. And I'm trying to see if they match up. Although this one's a little bit different. This one's not see if they match up. This one is figure out what A is to make them match up. So A minus 4 equals 3. So if A is 7, that would force them to match up.
So that's just basic algebra.
Yeah, I mean the
variable.
computation part is really simple, but knowing how to set it up,
Yeah.
set these two things equal to each other at 1, that means you're forcing them at 1 to come to the same spot. I mean, I don't know what this looks like, but parabola on one side and the line at the other, you're forcing them to match up so that it is continuous. All right, the last one I want to look at is 49, because it's this function that is supposed to be one of our parent functions now
Oh, yes.
that we know. Well, it's not the step function.
Staircase.
It's like unless you call it the one-step
Oh,
function.
the absolute
Did you
value.
put 7s in there just because I said I'd answer things in terms of 7?
I did not. That's actually number 49.
What number is this?
Number 49, sorry.
Oh, this is absolute value.
Well, but the top's absolute value, but absolute value over. Do you remember what?
Is 1.
So it's that graph that looks like this. At least there's the parent function. And again, you got to know that, because there's limits from the right and from the left, all sorts of things we can ask. What's a plus 7 do to the graph? If you stick a plus 7 in there with x, which way does that move it? Which way, though? Not up. Up would be a plus 7 out at the end.
Left.
But it's with 7, or it's with x,
Left.
so it's left and right. And it's with x, so it's backwards. So that means at negative 7 is where the break happens. And then the question was, find the x values that it's not continuous. Well, if you know the graph, it's not continuous at x equals negative 7. But I wanted you to see that picture again, because you will see it again next block day. Next block day is our test, if you didn't put that together. So it's not a hard one, and the answers aren't difficult, but you got to know what the picture looks like. Then you can answer all sorts of questions about left limits, right limits, functions, continuity, all sorts of stuff. All right, new stuff for today. It's kind of one calculus topic and one pre-cal topic.